So this video is going to be a quick example of how to apply the law of conservation of energy. And for this example, suppose that you just take a baseball, ignore the fact that it's bigger than your head, and let's say it's a 1.2 kilogram baseball and it's being thrown upwards with an initial speed of 15 meters per second. And let's say we want to know the speed of the baseball after it's traveled 6.0 meters. Okay, so the way that we would apply conservation of energy is first we would write down the basic idea, which is that the total mechanical energy initial is equal to the total mechanical energy final. And then what we have to do is determine what kind of energy it has at each point. And to make this a little bit clearer, we'll say that when you've let go of the baseball and it's traveling upwards, that's the initial point, and then when it's gone 6 meters upwards, that's the final point. So then we can take the potential energy initial and add to that the kinetic energy initial, and that's going to equal potential energy final plus kinetic energy final. Potential energy is mgh initial, kinetic is 1/2 mv initial squared, potential final is mgh final, and kinetic energy final is 1/2 mv final squared. Okay, so remember the trick for potential energy is that you always have to set a 0 point. So we're going to say that where the ball starts off, its initial height is 0. So it doesn't necessarily have to be the ground where the height is equal to 0. We don't actually know the height above the ground. So because we don't know that, we can't really use it. So we're just going to say that the initial height is 0 and the final height is going to be 6.0. Okay, so now what I can do is look at my equation and plug and chug, and the entire first term is going to be 0 because that initial height was 0. Okay, so then what we have left, all of the m's can cancel out, so we can have 1/2 15 meters per second squared equals 9.8 meters per second squared times 6.0 meters plus 1/2 v final squared. And so at this point I'll just do a little bit of math, and the first term on the left is going to be 112.5 meters squared per second squared. The first term on the right is going to be 58.8 meters squared per second squared, and then we have plus 1/2 m, I'm sorry, that m's gone, we just have plus 1/2 vf squared. So we do a little bit of math, and what we get is that v final squared is equal to 107.4 meters squared per second squared. Take the square root of each side, and we get a final answer of about 10.4 meters per second. Okay, and just as a check of common sense, it started with the v initial of 15, and when you throw things upwards they tend to slow down. So this makes sense. So that's one quick example of how to solve problems using conservation of energy.